to the side. So before we start writing notes, or before we start going through examples for your homework, I have a table of English to math, or how to translate from English to math. I posted it to Canvas, and we're going to look at it together for just a moment. It's not a huge topic of our course, but it's still going to come up in your other math classes, so we should, practice. I'm going to just go to our Canvas page. Just a moment, actually. Almost ready. Okay, we're in week 3, and so far all we have is this page, English to math. We've talked about 2 of these words. So far we used is means equals, or we can write is with this symbol over here on the right. And we used of. Of means multiply. So on the left sides are possible like words in a sentence, and then you can use the right side to translate it to math, from the English to the math. Some that we're going to get to today are like greater than or equal to, less than or equal to. And last time I sort of forgot this step, and I'll try to be sure to do it in the future. But if there's an unknown value, or it says what number or how much or just what, we give that thing a name. Usually we call it X. If there's an unknown value, label it somehow with usually some kind of letter or symbol that's easy to work with. Like a suggestion from the book was, if your unknown value is cookies, maybe use C for cookies. Or if your unknown value is something for a person named David, use D for David. But if it's like an unknown number, we're probably going to use X. Okay, so we want to know what % of 6 is 2.4. So for the part that says what, or maybe even what %, we're going to let X be that unknown percentage, or that unknown value. So we've defined our variable X, and then we're going to put this sentence together. So what % of X multiplied with 6? Of means multiply, and is means equals 2.4. I also suggest, for the most part, you're going to write down your mathematical statement as you read the sentence. So x times 6 equal to 2.4. And then solve for x. We will divide both sides by 6. So x will equal 2.4 divided by 6 was 0.4. And either you can multiply by 100 over 100, or I think we talked about moving the decimal place 2 times to the right. And you'd have 40%. It's asking for that percentage. Okay. We want to translate 7 is less than the product of, actually, yeah, just translate. And I may need your help on these sometimes, but for the most part, it should be clear. But just check how this is all going. The product of x and 5. So I don't have to solve anything. I just want to write this as math. So starting with 7 is less than, but just strictly less than the product of x and 5. So we're going to take x and multiply with 5. Let's go back there and just make sure that we know that this is that less than symbol. And for product, it means, multiply. X with 5. Cool. Again, we're just going to translate it. The difference of x and 12 is 4. Okay, difference is going to mean use subtraction. Difference of x and 12. So we want to take x and subtract 12 and then put it equal to 4. So just a reminder again, is means equals. Okay, moving on. So I want to make sure we go over a few for quotient. So the first one is to still translate. The quotient of x and 2 is 6. So for quotient, we're going to divide just make sure that you divide the first number by the following number and then use is for equals. Okay, so the quotient of x and 2 is 6. And that's the only goal, is just to write down what's going on, but in math. Okay, let's do the quotient of 7 and x is 12. Okay, so again, divide. But you divide the first number by the following number. So the quotient of 7 is x, the quotient of 7 and x is 7 divided by x. And then is means equals, and then to 12. And again, I just want to make sure the quotient questions are clear. So we want to do one more. The quotient of 20 and 4 is some number. If you don't know the number, you call it something. You define your variable. We're going to use x. Let x be the unknown number. And now we can try to write this as a sentence, or we could try to write this sentence as a math statement. Cool. So the quotient of divide 20 by 4 and it's equal to some number, we called it x. Which I mean, we could do another step, but really we want to translate this. We're not trying to solve, so I'm gonna leave it like that. I think I'd like to do one more and then sort of move on. Let's do this one. The difference of 16 and 2 times a number is 5. We're just going to translate. So translating this statement, let's first define that unknown number. So let x be your unknown number. So the difference of 16 and let's put this here, and 2 times a number, which means 2 times x. And for difference, we're going to subtract from 16, we're subtracting this 2 times x. And it is equals 5. Okay, I want to kind of finish up talking about homework 2, and the last kind of questions are about perimeter. And just a reminder that perimeter is the distance around the edge of a shape. Okay, I'm going to talk about a square, but we're going to move straight over to a rectangle. So for a rectangle, we're going to let W be the width and L is the length. And I have a question on the side. So our past meetings should be in the modules in Canvas, and they're sorted by week. So week 1 has the first 2 meetings, and then week 2 has the next 2 meetings. So just that'll be on the side. Share with everyone. Modules. Good question though. We're talking about a rectangle. We're going to let W be the width. And we're going to call L the length. I'm going to use capital L. And we'll draw a sketch. So we're trying to go around the edge of that shape, where we're going to call this side the length, and this side is the width. This side is just as long as that side, so this is also length, and this is also width. And we're going to use P for perimeter. Okay, width plus length plus width plus length. So 2W plus 2L. And then I'm going to help with doing a question similar to your homework, but a little bit different. So it asks about find the length and width of a rectangle. if the width is 2 inches more than the length. And the perimeter is 40 inches. Okay, so let's say you're doing scratch work. It's always good to kind of start with defining your variables. Even though we just talked about it, I would write down that W is going to be the width. L is going to be my length. And the equation that will be useful is for perimeter. So perimeter is P. It's equal to 2 times the length plus 2 times the width. Let's go back here first. We know that the width equals 2 inches more than the length. And just like kind of thinking through that again. The width is 2 inches more than the length. So whatever the length is, the width is that much plus 2. Now we can put in a little bit more info. We know that the perimeter is 40 inches. So that's going to sit right here. And at this time, I'm also going to replace W. W equals 2 plus L. And that way, when I have just one variable, L, I can solve for that variable. W is 2 plus L. And we're just going to keep on solving for L. Let's distribute 2. Do L, add 4, add another 2L. So 40 equal to 4L plus 4. Let's subtract 4 from each side. Okay, 36 equal to 4L. Then divide each side by 4. And you'll have solved for L. $36 over 4 is 9. So I have 9 for the length. I was also asked to find the width. Width was the length plus 2, or 2 plus L. So 2 plus 9. So that's it for notes on homework 2, which again is due tonight. I'll be back. We're going to start notes for homework 3 in just a moment. I need a timer. All right, let's do this. So the next topic is graphing, and mostly graphing points and lines. So straight lines, vertical lines, horizontal lines. That's mostly what we're doing this week. So when you're graphing, first thing we're going to talk about is a point. And a point is an ordered pair, x, y. We graph points on the rectangular coordinate system, which is also called the Cartesian coordinate system. Okay, so I mean the same thing. Rectangular coordinate system is the same as the Cartesian coordinate system. And that's where you have your x-axis and your y-axis. X is the horizontal, y is the vertical. The center is the origin. Right here we have 0, 0 is the origin. And it comes up sometimes in your math classes, the different quadrants. This one's called quadrant 1. This is quadrant 2, quadrant 3, quadrant 4. So you may see it in the future, like quadrant 1, Roman numerals, quadrant 2, quadrant 3, this over here is quadrant 4. I'm not going to talk about this very much. Ugh. I'm not going to use quadrants very much, but another teacher might. So at least you've seen this before. Mostly we're just going to be plotting points in our rectangular coordinate system. So let's graph the points -3, 2, and -1, 6. Let's do -1, -6. And one more. 0, -2. So something I've noticed, like let's say in a stats class or something, is sometimes the graph has the units kind of far and then close, then far and then close. Try to put them evenly spaced out when you do your sketch. It just makes it look more clear. So try to do like 1, 2, 3, 4, 5, 6. It doesn't have to be perfect, but just try to space them out the same distance apart. Okay, this way we're going to -infinity. This goes towards +infinity, and my x values are here. For y, this goes up to +infinity, down this way towards -infinity. So for -3, +2, you want to go -3 for x, up to +2 for y, and then that point right there is -3, 2. Plot -1, -6. So we're going to go here to -1 for x, down to -6. And the last one is 0, -2. So 0 for x, you're sitting right here, and then down to the y. And let's do the graph of a line. So to graph a line, you need 2 points, and then you can draw the line through those 2 points. Okay, and then draw a straight line through those points. Okay, we want to graph the line y equals 4x minus 1. I just need 2 points. Let's let x be, let's put in 0. And I'm going to try having x equal to 1. Okay, for the first one, if I put in x equals 0, I have y equal to 4 times 0 minus 1. So y equals -1. The other point, so I'll put this together in a moment. We got the point x equal to 0 and y equal to -1. Then there's the point where x equals 1, and you'll have y equal to 4 times 1 minus 1. Okay, y would be equal to 4 minus 1, so y is equal to 3. There's a point xy. First one was 0 for x, -1 for y. The other point I got was letting x equal 1, and when I did that, I got y equal to 3. So you need 2 points, any 2 points. I picked, just random numbers for my x values to get those points. Okay, so we're here with the point 0, -1. So 0 for x, -1 for y. And then 1, 3. Pull over 1 for x and up 3 for y. And then draw a straight line through those points. It's just a sketch, but still, I'm gonna try. Connect them with a nice straight line. Okay, so we are going to talk about vertical lines and horizontal lines. So the graph of the line of x equal to some number, where I'm going to choose the number 5. So we're going to use x equals 5, but it can be x equals any number. It is the set of all points with an x coordinate of 5. Since there is no y value, the y value can be any number. Yikes. Okay. Okay, so let's say we're looking at, how do we do this? So when you have x equal to 5, let's just write some points. We can have points that look like it has to be 5 for x and any number for y. So let's do 5, comma 2. Or let's do 5, negative 3. Or how about 5, 0? Maybe 5, 10. As long as 5 is your x value every time, and you can put any number here for y, that's a point on that line. So we can look at the graph now. You really just need 2 of these points and then connect them. But we're going to mark all of the points and then draw that line that goes through them. Okay, we're at 5, 2, 5 for x, up 2. And then 5, negative 3, over 5, down 3. And I'm also going to plot 5, 0. So over 5, and then right on the x-axis is 5, 0. And I could have 5, 10. There's too much over. It's like kind of up here somewhere, over 5 and up 10. So we're going up this way. X is stuck at 5. Y can go up or down. It can be any number. That's my vertical line. Last thing to talk about with these kinds of lines is the slope. Let's just put it as a note. Vertical lines have an undefined slope. Okay, we're talking about horizontal lines now. So the graph of the line y equal to 2. It is the set of all points whose y coordinate is 2. And this time, there's no x value. When there's no x, x can be anything. X can be any number. Okay, we're going to talk about just a few of the points that would be in the graph. So we could have x, any number, y has to be 2. Let's put x equal to -4 and then followed by 2. You can have 0, 2, or 1, 2, or 7, 2. Y has to equal 2. X can be anything I want it to be. Okay, so let's go here. -4, 2, -4 for x, and up 2 for y. I could use 0, 2, 0 for x, up 2 for y. 1, 2, over 1, up 2. I can have 7, 2. 1, 2, 3, 4, 7, up 2. There's my horizontal line. Y equals 2. So you go on your y-axis at 2, it's stuck there at 2, but x can go left and right. X can be any number from -infinity to +infinity. And another note, the slope of a horizontal line is 0. You've talked about solutions before, but now we're going to talk about a solution where there's 2 variables, like x and y. So it's a similar idea, a solution. To an equation two variables. Will be a pair of numbers that makes the equation a true statement. Okay, so we have a point. Oh, actually, we're going to say, is this point a solution? Is -2, 1 a solution to? Y equal to x minus 1. All right, you have -2 for your x value. 1 is going to equal y. And then we put those numbers in to see if this will be a true statement or a false statement. Y is replaced with 1. I have it equal to x as my -2, and then subtract 1. So it is 1 equal to -3. No, that would be false. So a false statement means that it's not a solution. Okay, is 3 -4 a solution to? Y equal to -3x plus 5. Okay, this time x is going to be 3. And y is -4. So I'm going to put -4 over here. -3 multiplied with +3. And then plus 5. Cool. So we're just seeing if this is true or false. I don't want to like manipulate the problem. Like you don't need to add or subtract anything from both sides. Just want to leave this here, copy that there, simplify this part over on this side. -9 plus 5. I got -4 equals -4, which is true. So 3 -4 is a solution. Okay, this little part of my notes is kind of to the side, a little bit off topic, but it's probably something we should have talked about in the review week. It's popular sets. So there are like big sets that are worked with are let's do popular sets. And we're going to start with the natural numbers. Excuse me. Excuse me, sorry. Okay, the natural numbers is the set that starts at 1, they're counting on your fingers numbers. 1, 2, 3, 4, 5, 6, 7, 8. And it keeps going on like that. The whole numbers is the same set, but it also has 0. So you start at 0, and then you go on to numbers you can count on your fingers. 1, 2, 3, 4, 5, 6. 0, and then 1, and then 2. They have to be positive, and they have to be, I guess, I don't know how else to say other than whole numbers. So keep going like that. And then you get to your integers, which include negative numbers. So it's a set, and it's coming from negative infinity over to something like -4, -3, -2, -1, 0, 1, 2, 3, keeps going. And then you close your set. And this is going to be on your homework. So I wanted to make sure we talked about what integers look like. So it's natural numbers, whole numbers, integers, and then you have the set of rational numbers, kind of like expanding our set each time. And we're going to say that this is the set of numbers that can be written as fractions. I think I will draw a picture once we're done with these sets, but we had the natural numbers, and then expands to whole numbers, then to integers, and then to rational numbers. But aside, totally separate from this set, are the irrational numbers. And they're numbers that can't be written as fractions. So there's a rational, there's the irrational, and then the kind of last set for us, the set that we stop at and that we work in most of our math classes, this class, probably your next class, is the set of real numbers. So the real numbers, so when I say let this be a real number, it means it could have been a fraction, it could have been a whole number, it's anything inside of the set of real numbers, where you could take your set of irrationals and the rationals. Let's put rationals first. Again, this is where we usually work in a math class, in our math class, in another math classes, like in a stats class, you'd be in the real numbers. There are some classes that go into the next popular set, which is called the complex numbers, but it's not in every math class. it's not going to happen in our class. But I'll still show you the last set that's like popular in the math world is the complex numbers. And we call them imaginary numbers. They exist. Their name is just imaginary numbers. I don't think we're even going to talk about that this semester. We're not going to even go into this set. So drawing a little sketch just to kind of picture what's going on. We started with natural numbers. And then in the natural numbers, we included 0, and that got us to the whole numbers. And then we went on to the integers, which is the whole numbers and then also negatives of those numbers. After that, we had the rational numbers, where you can have things like 1/2 or -3/5, things that can be written as fractions. Okay, things that can't be written as fractions are over here, and those were the irrationals. And for our class, we can use any of these numbers, or we can use any of the irrational numbers. We're going to put them all together, and that's called the set of real numbers. Okay, so back to talking about lines. So find 2 integer solutions to x equals -5. All right, I'm going to find a few points. We only need 2 points, so let's set those up. This is my x. This is where I put y. X has to be -5. So I'll start there in both of my points. Okay, and then this part says, well, this part tells me y can be any number, but the question has restricted it to an integer. So it can be 1, 2, 3, 4, 5. It could be -1, 2, 3, 4, 5, 6, 7. It could be 0. It just has to be some integer. And then we're going to graph. I will plot those points First one is -5 for x, 0 for y. And then there's -5 for x, and we're going to go down 3 for y. And then connect. Oh, let's try this. It's going through -5. Okay. Let's do something like this one again. Find two integer solutions to, oh, we're almost out of time. Okay, to find two integer solutions to y equals -3. And then graph. Okay, so I need 2 points, x, y. Y has to be -3, so I'll start there. Okay, there's no x, so x can be any number, but they're asking for it to be an integer. So for my x value, it can be something like -4, and I can put a positive, let's go with 4, and then graph. So you're going -4 for x, down 3 for y. +4 for x, down 3 for y. And then a straight line through those points. To get y equal to -3. So when we come back on Thursday, we need to talk about x and y intercepts, finding the slope of a line, and then using the point slope form to get the equation of a line. And then just practice graphing lots of lines. Cool. That's it for today. Thank you, everyone.